Hello, everyone. My name is Ian McLaughlin, and I have a PhD in neuroscience. And today I'd like to talk about a topic that I've discussed a fair bit in the past, a substance that's undergone a bit of a renaissance over the past few years, cannabis. So cannabis is a massive topic, and its pharmacology is massively complicated, due in part to this wave of state-level legalization that's happened over the past, well, kind of sort of a long time, actually. But despite the sustained status of cannabis as quite illegal at the federal level, there's been this kind of sustained and growing interest in understanding the basic neurobiology of how it is that this complicated plant affects the human nervous system. Hey, Marcia, thank you, or Marcia. I'm not 100% sure if it's Marcia or Marcia, but hey, thanks for joining. Hey, Scott. Oh, thank you very much, Georgia. Thanks for hopping in. I appreciate the award. Okay, and so to give you a sense of sort of where we're at in this country, at least, and I apologize for beginning a bit sort of United States centric, but I do think that this is an unfortunate case of United States domestic policy driving international policy. But just to give you a sense of where the country is, so you're obviously looking at a map of the country, and you're seeing 4 different colors that indicate 4 different legalization statuses. So totally illegal, gray. Legalized for medical use, that's sort of light kind of aquamarine-ish color. Decriminalized, that's sort of dark blue greenish color. And then legal for recreational use, totally legal, bright green. And remember, this is at the state level. So I happen to know that this map isn't entirely up to date because I know that New Jersey would be that bright green color as of just a few months ago. But I think that this sort of conveys the point that the number of states in which cannabis remains entirely illegal is in the very, very small minority, only 6 states. And so the rest have some form of legal status assigned to cannabis. Hey, Cosmic Rose, howdy. VA is decriminalized also. Yeah. There's definitely some different. Yeah, right. That happened kind of recently as well. Yeah. But now, of course, this doesn't speak at all to the state of affairs at the federal level, which is an entirely different can of weeds. But I think you get the point, right? The vast majority of states have found a reason to provide some kind of legal compensation or consumption of this substance, right? Either exclusively for medical purposes or irrespective of whether it's for medical or just purely recreational reasons, right? And there are a few holdouts, clearly, obviously, but I think we can see the way the wind's blowing here. But if we look to the rest of the world, we get a different picture. And so, with all that bright red, that indicates countries where cannabis is both illegal and that illegality is enforced. Okay, pink is where it's technically illegal, but that illegality isn't really meaningfully enforced. Like nobody cares. It's on the books, but nobody cares. Orange is countries where cannabis is technically illegal, but decriminalized, right? So sort of functionally legalized. And then in blue, we have countries and some states, obviously, where it's just straight up legal, right? And then, of course, we have countries where exclusively penguins smoke pot in gray. And so, I'm unsure how up to date this world map is, but I imagine it's fairly accurately representing the state of affairs globally, right? And so, all this to say, a lot of progress to be made internationally regarding the use of the substance. So as I mentioned, right, the pharmacology of cannabis and cannabinoids is complicated, right? In short, cannabis is a plant, obviously, right? But it produces a huge variety of molecules, some of which have interesting pharmacological effects. The most well-known molecules produced by cannabis are likely familiar to anybody who might be listening to this, THC or tetrahydrocannabinol, and CBD, cannabidiol. But there are tons of cannabinoids that have been identified in this plant. And honestly, I've seen different studies claim different numbers of distinct cannabinoid molecules. And I'll try and include a link if anybody's interested in the chat. Hello, 47 Gold Prince. Thanks for joining. Buenos tardes. Buenos tardes. Buenos. So, so I've seen different studies claim different numbers of distinct cannabinoid molecules. And so, yeah, I'll try and link, if anybody's interested, I'll link it in the chat here at HAPS. But the point is, there have been claims that over 100 have been identified, but for our purposes, the point is that, there are many more cannabinoids produced by this plant than just THC and CBD. So, but even beyond solely cannabinoids like THC and CBD, the plant produces a whole variety of additional interesting molecules that have interesting properties. And it's those fatty, sort of sticky molecules on which this study focuses, terpenes. So This is a study out of the University of Arizona, and it's really a behavioral and electrophysiology study, okay, where scientists try to get a sense of how it is that various molecules affect humans by seeing how they affect certain animals. And in this case, it's our cherished biomedical ally, the mouse. And so the group did at least, one of the same behavioral tests that I used to do when I was in the lab, and also happened to use some of the same software that I used when I was in the lab. So it's pretty cool. They have good taste. Thank you so much, Jeff's Journey. I appreciate the award, man. And so, hey, Max, following you since 2016 on Periscope. Oh, that's awesome. Thanks for, I appreciate you telling me that. I always love hearing that. Thanks for joining here. So, okay, so I know the term like electrophysiology is probably one of those words that isn't particularly meaningful to a lot of people. That's just when neuroscientists use tools to get a sense of what very specific parts of the brain, even specific brain cells, or even parts of specific brain cells, to get a sense of what those very specific parts of the brain are doing at any one moment, right? We can get a sense of what one out of our approximately 86 billion neurons it becomes particularly chatty, right? Causing a bunch of other neurons, brain cells, to either become super active or just to completely shut down and become silent, right? Electrophysiology is one of the tools that we use to do that. And so it's sort of like if you were standing outside of a room in which people are having a conversation and you really want to know what they're saying, but you can't hear a single thing because the door's closed. But then all of a sudden you stick a microphone on a long pole under the door and all of a sudden you hear every single word. That's kind of like what electrophysiology is about. Kind of, sort of. Okay, so this is a group who's getting a sense of how it is that specific molecules change behavior, okay? And then also getting a sense of how those molecules change activity in the brain. Pretty cool. By the way, it's basically what the next paper on which I'm an author did, but different drugs, different brain regions. Okay, so also it's actually a drug that people also smoke, nicotine. So once again, what makes this study interesting isn't that they're focusing on cannabis, which is interesting. It's a substance that's been receiving among the greatest rises in attention in biomedical science, and more importantly, enjoying this wave of state-level legalization, right? So an important thing to study. But what makes this study interesting is that they're focusing on the terpenes that the plant produces. Okay, so what are terpenes? These are the things that the plant produces that makes cannabis have that immediately recognizable smell. And so here's... here we go. Okay, here, and I should probably do this too because it's kind of a complicated picture. Very pretty though. Okay, and so to people who are aficionados of cannabis, right? These are the molecules that distinguish varieties of cannabis that have unique olfactory or odorant characteristics, right? Think like OG Kush versus Sour Diesel, right? They're what make cannabis smell citrusy or piney or berryish or minty, skunky, right? All those kinds of smells. And as you can see here, they're breaking it down into spicy, sweet, sour, and earthy. Which probably actually correspond pretty nicely to the terpenes we're going to talk about. But depending upon specifically which combination of terpenes are present in the plant, you'll get differences in smells. Sort of like how a Honeycrisp apple tastes both similar, obviously it's an apple, but tastes similar as well as pretty different relative to a Red Delicious apple, which by the way, I am continually baffled when I see someone actually still buying a Red Delicious apple instead of like a Honeycrisp or a Cosmic Crisp or my favorite, the Sweet Tango. But anyways, smells, same smells for wine. Yeah, well, similar kind of concept going on for sure, right? That's why, different wines have different, flavor profiles. I can't say for sure that they are terpene molecules that are what are responsible for, the difference between like a Merlot and a Cabernet or whatever, or Zinfandel. But similar idea for sure, right? Different depending upon which molecules are present in that wine, you're going to get different flavors as well as different like feelings, right? I assume you are pro cannabis. I'm certainly for legalization. I'm not pro any one drug, but I think that the prohibition on cannabis has been one of the most damaging and asinine policies in the history of this country, and with demonstrable effects. And even on its own terms, for the goal, the goals underlying the purported goals underlying cannabis prohibition, even judging based on its goals, it's a failure, right? People still smoke a lot of pot and have for years, right? But beyond just those goals, I don't think that that's a good goal to have, anyways. But beyond just that, I think it's demonstrably been one of the most damaging policies in the history of this country, and it disproportionately affects some people more than others. Okay, so the same kind of terpenes that are in tea tree essential oil. Yes, now we're getting, yes. So a lot of essential oils have terpenes in them, but essential oils are a little bit different because they're not necessarily an isolated terpene. They're essentially an extract of a plant or some kind of thing, right? So you're not just getting one terpene; you're getting sort of like a bunch of them. But yeah, I mean, similar idea, right? That's why they smell different, or smell differently. No, they smell different. Okay, so terpenes are found all over the place, right? As we're talking about, they're largely produced in plants. More on that later. But there are even terpenes that are produced by animals, like squalene, for example. So squalene is one of those words that's also just sort of like aesthetically unfortunate to say, squalene, but it's in a ton of trendy skincare products, right? That you might have seen on the shelves in one of the fancy skincare stores. Squalene is a terpene, and while it is found in plants, as the ordinary product says that's where they're driving their plant or their squalene. It was originally derived from shark liver oil. It's also, squalene is an important molecule. Squalene is important to the synthesis of plant sterols like cholesterol, as well as the steroids that our own bodies produce, cholesterol. And so, it's a pretty important molecule, and it's important enough that both plants and animals produce it. Pretty cool. Okay. So anyways, these molecules, the terpenes, they're which are the sort of sticky and fatty molecules, are produced in the same part of the plant that produce molecules like THC and CBD. So here we go. Boom. So the term trichome is actually derived from a Greek term referring to hair. Then you can sort of see why in these pictures, right? They're sort of like these little protuberances that look almost like fur, right, on a plant. But plants don't necessarily have fur technically, but they contain a whole variety of molecules that, at least in some plants, like cannabis, for example, has some interesting interactions with the human body and nervous system. And so, by the way, they're sometimes called resin glands or just resin by, devotees of the plant. Same things, referring to the same things. More preposterous than the alcohol prohibition in the 1920s. Yeah, that was so bad that, it was rapidly rescinded. By the way, in my office, I have an antique of during Prohibition. One of the ways that people got around it, I assume wealthier people got around it, it was by getting prescriptions for alcohol. And it's not like they're rare or anything like that, but I have like a framed prescription for alcohol, and I just like it because I feel like it's a reminder of like what happens when you try and prohibit people from doing something like that. Just a good reminder when legislating. And so, Georgia, you have one of those products? Yeah, right on. I know The Ordinary is like an extremely popular brand. But anyways, yeah, squalene is in a ton of products. Tannins, yeah, there you go. For when it comes to wine, right? Blazing Blasphemer. You might dig this topic today, but yeah, so tannins, right? And tannins are not terpenes, but tannins would be responsible for like changing what it feels like to drink wine on your tongue, right? That gritty feeling. But yeah, a good point, right? Like how many tannins are included in a wine will affect that. Similarly to which terpenes are present will affect flavor profiles. Yeah, good comparison. So for my fellow plant nerds, trichomes come in many shapes and sizes. I mean, I guess not like that many shapes and sizes, right? They all kind of have a similar theme, but everything from algae to lichen to plants have trichomes, only some of which are glandular, right? Which is what's going on in cannabis. And so the whole concept here is that in plants with glandular trichomes, there are interesting molecules secreted within them, and molecules that are byproduct of the plant's growth, right? And so, so these are the molecules on which this group is focusing for their study, terpenes, of which there are many, to be clear, and which determine the unique odors of various strains of cannabis, which are produced in these little hairy thingies on the buds of the cannabis plant. You could think of buds as a sort of like cannabis flower, right? And just to be clear, some of these terpenes aren't unique to cannabis. So for example, the most common terpene in cannabis extracts, though it's technically a terpenoid because it contains oxygen in the molecule, but it's still in the same category. It's a terpene, whatever. Anyways, the most common terpenoid in cannabis extracts is present in a ton of the foods that you all likely eat. So basil, oregano, black pepper, rosemary, one of my favorites, and a bunch of others all contain this molecule, beta-caryophyllene. Okay, and so this molecule, which once again is found in all those herbs that are probably in your spice cabinet or growing in your garden, using basically any interesting meal you've ever had, right? This molecule is a cannabinoid receptor agonist. meaning that it activates some of the same receptors that the sort of more prominently active ingredients of cannabis activate, right? Cannabinoid receptors. So these aren't molecules that are only found in cannabis. Keep that in mind. Okay. So there have been, some interesting studies that suggest that different terpenes may have interesting biological effects. Okay, things like altering the way that animals react to caffeine, for example. And I'll, if anybody's interested in that, I'm happy to include a link to that study as well. Well, it's actually just a great review of these effects from like a few years ago, 2017, I believe. And it's pretty extensive. But what's cool about it is that it also goes into a bunch of the cannabinoids that I suspect are unfamiliar to most people: cannabichromene, cannabigerol, right? And it's also freely available, right? So you don't have to subscribe for it. There's no paywall. So just let me know if you want a link to that, and I'll share it. Glandular, hello, yeah. Kimchi, I figured you'd be here. Beta carotene, no, beta caryophyllene. So yeah, I don't worry about the term, but yeah, I mean, that's just a terpene that's present in probably stuff that you have at your house right now, if you cook it all, if you have like an herb garden. So yeah, anyway, so let's get to the study for today. And so here's the main question that this group is asking. Is there an entourage effect? Okay, meaning, does the combination of the molecules that we know are psychoactive in cannabis, THC, CBD, and so on, right? Does the combination of those psychoactive molecules with the molecules that give cannabis strains their unique smells and flavors actually change the effects of the strain? And when I say effects, the group explored a bunch of different effects, and we'll get into that a little bit more deeply later. But their main finding, these terpenes, the specific terpenes that this group really interrogated, they actually mimic the effects of THC itself. So this group honed in on just a specific handful of terpenes and terpenoids, which, remember, are, terpenoids are just terpenes that contain some oxygen. That's it. Not really important. They're both, they're all just this fatty, sticky molecules that are produced in those trichomes, those, glands, right? And so some of the ones that I find sort of particularly interesting or fascinating, at least, that they dove into are linalool, which smells kind of like lavender, or like a citrusy lavender, evidently, as well as beta pinene, which smells like that unmistakable and very lovely pine scent. But they scrutinized a few additional ones, right? They explored alpha humulene, which evidently smells like hops. Those hops, right, that are used to make beer, which is a pretty similar plant, by the way, the hops plant compared to the cannabis plant. But evidently the molecules smell sort of like hops, woodsy, earthy, and so on, right? And they also looked into a geraniol, right, which evidently smells a bit like roses, but it's also present in citronella oil. Pretty cool. And by the way, these molecules tend to be pretty simple molecules. Here, I'll prove that to you. I think I have one here. Yeah, here we go. We can get rid of the pretty trichome pictures. Okay, so yeah, pretty simple molecules, right? And so, and you can, this is the geraniol molecule, right? Pretty simple molecule. It's just like a couple of, it's just a hydrocarbon essentially with an alcohol group. So it's probably a terpenoid actually, but anyways. So they honed in on these particular terpenes because they're found at particularly high concentrations in cannabis, right? Though some of them are at higher concentrations than others, or they tend to be, okay? And so there's a sort of complicated pharmacological study, or set of experiments in this study that they did. They were working with the cannabinoid that's really quite different in terms of its molecular structure compared to the more standard cannabinoids like THC and CBD. And here I'll show you. So here we go. So they're working with a cannabinoid called Win55-212-2. Okay, we'll just call it Win55. So I know looking at this molecular structure isn't like particularly informative, just a bunch of hexagons and pentagons with some letters and lines and stuff, right? But let's compare it to THC. Here we go. Okay, so again, I know a bunch more hexagons and stuff, but you don't really have to have a PhD in organic chemistry to get a sense that these are pretty significantly different shapes, right? Different numbers of hexagons and pentagons, different letters within that pattern of shapes. And then THC has that lovely long tail, while Win55 has that big old hexagon hanging off of its tail. These are different molecules, right? So Scott says, fun fact, Elliot Ness was the safety director here in Cleveland after his stint leading the Untouchables. Huh, I did not know that. So yeah, beta caryophyllene. I forgot to mention that the one IPA called Hemperor has the same terpenes apparently. Cool. Yeah. So both of these molecules, despite being pretty different, bind cannabinoid receptors. And Win55 is not produced by cannabis. So they were working with trying to get a sense of whether terpenes, both on their own as well as in combination with a molecule that isn't THC or CBD or produced in cannabis, whether these terpenes have their own effects and or if they alter the effects of what happens when our cannabinoid receptors, the receptors that THC bind, if they alter the effects of when those receptors are stimulated, okay? And so before we dive directly into what they found, we have to talk a little bit about a bit of terminology that's kind of central to how scientists interrogate, the endocannabinoid signaling system, the receptors to which THC and CBD bind. The entire system, is affected by THC and CBD, right? But the system is extremely broad and complicated and influences a ton of our consciousness and our experience, far more than I suspect a lot of folks who have experience with cannabis might themselves suspect. But all this to say, we have to talk about the tetrad model. And so the tetrad model is just a word to describe 4 specific categories of effects that molecules that interact with cannabinoid receptors induce in animals, okay? Hypolocomotion, which just means animals sort of, including humans, sort of slowing down and not moving around so much. Hypothermia, which means that body temperatures drop a bit. Analgesia, which means sensitivity to pain decreases, and catalepsy, which in this context, when it comes to this specific application, means a tendency to not be driven to move very much, right? Even if someone's in a sort of like uncomfortable position, right? So that's the tetrad. Animals tend to move around less while they're moving. We tend to not really want to move very much at all. We tend to have lower body temperatures and reduced sensitivity to pain. That's the tetrad. Okay. Thank you very much for the award, George. I really appreciate that. Okay, so here we go. Where's their tetrad? Here he is. Here he is. What? Here it is. Okay, so so this is where this group begins, right, with the tetrad model. And I know this is kind of a wacky figure. It's called a radar chart, and honestly, I kind of love it, but I know it's a little bit inscrutable. But so the farther you move from the center, the stronger the effect towards one of the cannabinoid-related effects of the tetrad, right? The different colors are representing how significantly each of those 4 terpenes that they studied induced each of those 4 effects in the tetrad. And you can see them in different colors. You can see them listed along the top. Thank you so much for the Got Talent Award. I appreciate that. Pizza, Pop-Tarts, pot. That's awesome. Good combo. Okay. And so okay. This figure, you can see, for example, that pinene, which is that sort of blue kite-shaped thing, induced a pretty significant change in how mobile the animals were, right? Well, it didn't really have much of an effect on any of the other 3 effects. But then geraniol, that terpene that smells sort of like roses, had a pretty cataleptic effect, making animals just sort of like linger in a body position that's just kind of like awkward, like a position from which most animals would move pretty rapidly if they were sober. And so, keep in mind, this molecule, Win55, that molecule that stimulates the same receptors that THC does, but isn't found in cannabis at all, right? They're comparing changes in these behaviors to what happens in animals when they're given Win55, okay? In other words, what happens when the same cannabinoid receptors that THC stimulates, right, or activates, are stimulated, but using a molecule that isn't even found in cannabis, right? So it's not an interaction between these terpenes and like a molecular interaction between these terpenes and THC or CBD, right? It is specifically about when the receptor itself is being stimulated. Okay, and so what we're seeing is that these 4 terpenes, the 4 different color polygons, right, in this figure, they seem to influence the same effects, the classic effects of cannabinoids, but in different ways, right? These aren't congruent, right? There's not just like one sort of diamond-shaped thing so that they're all influencing, the 4 tetrad effects in the same way. Rather, there's some differences between them. Pretty interesting. What does that mean? So that means that if an animal were to consume or smoke or vaporize or whatever, a strain of or an extract of cannabis that happened to have quite a bit more, let's say, geraniol, right? That rose-like scent, or scent. And to be clear, geraniol is also used in flavor combinations to achieve a whole bunch of like fruity flavors, like grapefruit, apple, and blueberry, by the way. So it's not like just rose. But anyway, so strains that have high concentrations of geraniol may very well be more likely to cause someone to just sort of like stay stuck to their couch lock, in other words. However, if that animal were to consume a strain that happens to be high in, alpha-humulene, right, which is that terpene that has that sort of hopsy, woodsy kind of characteristic, that's also found in basil and rosemary, right? According to these data, that animal wouldn't seem to be particularly immobile at all, right? So that's what this radar chart is showing us. So keep in mind, this is in mice, right? And it's always worth remembering that, while our nervous systems are remarkably similar as far as, different animals go, right? There are obviously some pretty substantial differences as well. So these data shouldn't be interpreted as like indicating that a certain strain that happens to be super high in one of these terpenes will most definitely equate to certain effects in humans. Rather, what these data show is that there appear to be meaningful differences in the behaviors of mice whose cannabinoid receptors are being stimulated, right? Between these terpenes, right? And so, the data suggests that there's something to the claims that there are meaningful differences between, the massive variety of strains of cannabis. But it's far, far more complicated than just ratios of THC to CBD. So this group did a whole bunch of pharmacological experiments to try and figure out if these, terpene molecules interact with cannabinoid receptors on their own directly, right? Even in the absence of any actual molecule that we know binds, cannabinoid receptors like THC or Win55 in this study. I honestly don't think it would be particularly edifying to go through those data because they are pretty like nitty gritty classic pharmacological experiments, and we'd have to like go through a bunch of different terminology. But the short story is when they checked out if these molecules might be able to interact with cannabinoid receptors directly, basically in a test tube, it looks like they might be able to. So it's possible that these terpenes, these molecules that are the main reason that different strains of cannabis have different odors, it's possible that they not only influence the nature of the effect that different strains have, but they might even interact with the same system that the sort of main active ingredients of cannabis influence. So in other words, they may have their own meaningful cannabinergic, right, or cannabis-associated effects, right? They may contribute to the overall effect of cannabis by binding cannabinoid receptors on their own, or modifying the reaction of cannabinoid receptors when they're bound by things like THC or CBD. So another neat thing about this study, so they explored whether these molecules interact with a certain receptor that you may never have heard of, but you're almost certainly intimately familiar with the role it plays in your daily life and are very likely antagonizing this neurotransmitter receptor at this very moment. If you've had any coffee or tea or Coca-Cola today, the adenosine receptor. So what do coffee, tea, and Coca-Cola have in common? They're all drugs, or miraculously, they all contain a drug in them, caffeine, right? So the stimulant caffeine, one of the most widely consumed drugs in the world, happens to have pretty strange pharmacological effects, right? As far as like stimulants go. It's an antagonist at an adenosine receptor. And so in other words, caffeine basically prevents that specific receptor from being stimulated. It basically gets in the way and it prevents a neurotransmitter that would normally bind it, adenosine. It prevents adenosine from binding the receptor. Thank you very much, Pizza Pop-Tarts Pot. And so the possibility of future build a strain is mind-blowing. Totally, yeah. I mean, people are kind of sort of doing that, right? With sort of like selective breeding and stuff. Really interesting. Yeah, the potential variability in cannabis is pretty astronomical, just because of how complicated the genetics of that plant is and how they reproduce. Pretty interesting stuff. And then, of course, the prospect of it's going to be a pretty profitable industry. It already is really profitable industry. And so the prospect of like just straight up gene editing, like it's probably not completely unrealistic. But anyway, so back to caffeine, right? It prevents adenosine, the neurotransmitter, from binding its receptor. And so that's what stimulates us when we have caffeine, right? Because the neurotransmitter adenosine builds up as we're awake for longer and longer, right? Sort of like a biological clock. Right? The longer we're awake, the more adenosine is building up in our brain, binding adenosine receptors, making us sleepier and sleepier, right? But with caffeine on board, it's like our brain has no clue that this neurotransmitter is building up because caffeine's preventing it from binding. And so that's the adenosine receptor in a sort of nutshell, okay? A small nutshell, but it's all way more complicated than that because it also acts as a sort of counterbalance to dopamine actually in regulating body movements, which is why it's a target for the treatment of Parkinson's disease. More on that a little bit later, but the point is that this lesser known receptor is associated with how much energy we feel like we have and how much we'll tend to move. So for example, when someone's just had 2 cups of coffee or espresso or a Red Bull or energy drink or whatever, and you see their knee sort of like jittering, bumping up and down, right? That's because there's a whole bunch of dopamine and other catecholamines flowing, but basically zero adenosine receptor binding, right? Because there's just like a ton of caffeine in their brain standing in the way. And so they will tend to just move more. So, okay, I know it's not a particularly sexy story, but hopefully that gives you a sense of why the data that this group collected regarding terpenes and the adenosine receptor are intriguing. So let's get to those data. Here we go. Yeah, I guess we can do this. Okay, that's probably a little too small. Let's do that. Okay, so this is a super duper uncool figure. I know it doesn't get much more boring than bar graphs, but I understand. But just stick with me. This is actually pretty cool. So what we're looking at is how much their mice moved around. Okay, that might sound like a pretty ridiculous thing to measure, but when it comes to mice, they tend to move around, walk around about at similar levels, right? Just in the same period of time, same conditions, they'll tend to walk around about the same amount. So it's a little bit more complicated than that, as always, but they just tend to behave pretty similarly under similar conditions. So what we're looking at is how much time they moved around, right? The higher the bar, the more they moved around. And so you see that dotted line, black one, the black top dotted line, that's how much mice normally boogie, right? That's how much they normally move around. And so it's sort of like the baseline mouse behavior. And so, to be clear, like every one of these treatments, each of the bars is slowing the mice down, right? But some way more than others. And so let's start with the bar that's sort of stripy with the star over it. Istradefylline, that's what that word is. That's how that word is pronounced. Istradefylline is a Parkinson's medication. Actually, fairly recently, a Parkinson's medication in the United States. It's been used for much longer, I think since like the 90s in Japan and other countries too. But very recently it was approved here. But I know that this sounds like a whole big can of worms, and what does this have to do with cannabis? Just stick with me. You can basically think of istradefylline as basically caffeine, right? But an even more targeted version of caffeine, targeted at a specific receptor. So like the difference between throwing a dart at a dartboard and throwing like a basketball at a dartboard. Istradefylline is the dart, caffeine is the basketball, okay? It's way more targeted at a certain adenosine receptor, A2A. So istradefylline will tend to prevent hypolocomotion because it blocks things from getting to binding that adenosine receptor. It gets in the way, okay? And so if someone is trying to, if a molecule, right, is trying to bind that receptor, let's say adenosine, but istradefylline is on board, no dice, right? It can't bind the adenosine receptor. And as you can see, that bar is pretty high compared to the other ones, right? So those mice are moving around a lot more, significantly more, in fact. But then on the other side of the figure, we're seeing geraniol, which is, again, one of the terpenes found in cannabis, the one that smells sort of rosy and is present in citronella. That's just straight up geraniol alone, okay? Nothing else. Now, do you see that red dotted line? That's the effect of Win55, that cannabinoid that might as well be THC. And I know I'm saying that a lot, like this drug might as well be that other drug. There's some good reasons for why they didn't go with THC or they didn't go with just caffeine. There's some good reasons, believe me, but you can just think of it that way. So that red dotted line is how much Win55 causes mice alone. Just Win55 causes mice to just kind of relax and stop moving around, right? Geraniol alone caused them to relax even more than Win55. And then right next to geraniol, that bar, that checkered bar, that's what happened when mice got both geraniol and Win55, a combination. And as you can see, they tended to get even more chilled out. And so the white bar is pretty informative. And here's where I probably would have done this figure a little bit differently. But rimonabant is essentially the opposite of THC or Win55. It's like if THC or Win55 is stepping on the brakes, rimonabant is the gas pedal, okay? And as you can see, there's really no big difference when mice were given rimonabant. It's like it doesn't really matter that rimonabant is on board. They're behaving just as they were with geraniol or geraniol plus one Win55. But then we return to istradefylline, the stripy bar. All of a sudden, major change. The mice aren't nearly as chilled out. In fact, they're statistically significantly less chilled out. They're moving around way more. And so what does that tell us? This is like, old school pharmacology, right? It suggests that, first of all, geraniol seems to have some interesting effects on its own, okay? Also, there seems to be an interesting interaction with Win55, which means that there seems to be an interesting interaction between geraniol, between geraniol and cannabinoid receptors. But it also seems that rather than exerting its chillaxing effects via the endocannabinoid receptor, geraniol seems to at least depend upon adenosine receptors being available and not blocked, right? Not antagonized. That's what we can tell from that stripy bar. Okay, so there's a ton more to same adenosyl as adenosylcobalamin. I'm not familiar with that molecule. Adenosine, SINE. It's an amino acid, which is kind of weird, but adenosine. Not adenosyl. Maybe adenosyl is like an analog of adenosine. I'm not sure. I'm unfamiliar with the molecule. I can check that out later, but there's a lot more to this study. They did a lot more than just that. They did that kind of experiment that we just talked about with all of the tetrad cannabinoid effects, right? For each of the terpenes that they tested. And what they found was that they basically seemed, these terpenes seemed to be capable of inducing cannabinoid-like effects. And that some of the terpenes seem to have some kind of interesting interaction with the adenosine signaling system. The story's more complicated than that, but I'll be honest, this was pretty surprising to me. I didn't expect these results. And there are a few provocative things about this study. And so, yeah, like I didn't expect this because, well, there are a few provocative things about this study. So first of all, the whole notion that these smelly, sticky terpenes actually have some meaningful influence in the effects of cannabis, and therefore, cannabinoids, actually contradicts past studies. They have some pretty reasonable explanations for why it is that they think that they came to these different conclusions. While the past studies came to essentially the opposite conclusions, which in part revolves around, their explanations revolve around basically the high concentrations of the terpenes that were examined, as well as how they treated each terpene individually, as opposed to like combining them all into like a soup, and then just sort of like cranking up the combination of one of them in the soup, but cranking up the volume of an ingredient. Mixing metaphors here. But anyways, it's provocative because they're contradicting past studies. But there are some methodological differences between those studies, which may account for why they had such different results. But it's also provocative because their data suggests that these smelly terpenes can add to the effects of cannabinoids. They have effects on their own, but when they're combined with cannabinoids, there can be an additive effect. Pretty interesting. And depending upon which terpene is present, you'll get an additive effect in different directions, right? Thank you so much, Kinchi. I really appreciate that that award, the Namaste. Ian, so sorry you speak so fast, it's hard to understand exactly. Yes, I know. I've been told that before. I'll do my best to slow down. Okay. Maybe I need some geraniol. So yeah, provocative. And of course, there's always things about any study that are worthy of criticism, and I do think that they're probably pushing their own interpretation of their data a bit further than I would. But it is a pretty interesting set of experiments, and the data are interesting, and I'd love to see like a broader set of terpenes examined, like high throughput receptor binding, that kind of stuff. Just like throw the kitchen sink at that, at a study like that, and just see, hey, do these terpenes bind cannabinoid receptors? I mean, it's not that hard of a study to do. It's expensive, and not that many people with the equipment necessary are sort of capable of doing it. But it could be like a one and done type of experiment, just to see like if these terpenes are binding cannabinoid receptors. That's huge. I mean, it's in the scope of human experience, it's not necessarily that huge, but it's huge pharmacologically. It's huge for the cannabinoid industry and for patients who are using cannabis for various maladies, pain, for example, but also anxiety, these types of things. And I'd also love to see more like molecular and circuit research to really get a sense of like, okay, so we're seeing this interesting interaction, but are there differences in how these different terpenes change circuit activity within the brain? Like that would be fun to see. But so, okay, what's the answer to the question? Does the smell matter, right? Does the smell of cannabis matter? Does the scent of cannabis affect the effects of cannabis? And the answer to that question, at least according to these data, seems to be yes, which honestly is pretty cool. And I'll admit that my assumption going in has always been that, well, I mean, of course it matters, right? But only insofar as the odors of anything influences our experience of that thing, right? The odors of a wine influence that thing, right? But it's not like there's a meaningful pharmacological difference between like what happens in my body when I eat a Honeycrisp apple versus a Red Delicious apple, which I would never do, by the way. But anyways, it's not like there's a pharmacological difference between those apples. They just taste differently. They taste different. But anyway, so these data suggest that there's not only a sensory experience of one strain of cannabis smelling unique, right? Which is, you don't need a lot of evidence to suggest that that's the case. Rather, the same thing that causes those unique odors seem to also be associated with a unique pharmacological profile, right? Pharmacological effect. And, given that one of the cannabis tetrad effects happens to be analgesia, or the reduction of pain, this possibility that terpenes can at least influence the efficacy of cannabinoids themselves may help to more, scrupulously and accurately identify optimal strains of cannabis for folks who are looking for ways to manage pain, right? With a medication that isn't an opioid. And with the number of people who are being lost every year to drug overdose fatalities, we're coming close to 100,000 people, the vast majority of whom are lost due to opioid overdose fatalities. And while the majority of them are not passing away from their prescription opioids, it does happen. These data, these findings can help potentially if they pan out, if there's more confirmatory studies that are performed. This may enable us to, like, rather than just like, the sort of anecdotal evidence of which there's a lot in the cannabis community, where it's like this strain is more stimulating, and all the wrong sort of like taxonomic terms are used. Like sativas tend to be more stimulating and stimulate creativity, whereas indicas tend to be more sort of sedating and couch locky and analgesic, right? But putting that aside, right, we could actually get to this strain has X concentration of geraniol plus, pinene, right? That would equate to, a certain FX profile if these data are correct. And so it'll be interesting to see, right? As more terpenes are studied, how do these findings map onto what people already know about their experiences of various strains, right? Like when somebody smokes OG Kush, right? They have certain expectations, right, of the effects versus like sour diesel or something like that, right? And so yeah, it's going to be interesting to watch. This was published in a reasonably high impact factor journal. People are going to read it, and so it'll be cool to see where they go with this. Gonna have to replay this. Oh, that's CBAD Veda, but thank you for joining anyways. I have a certain expectations for Gorilla Glue number 4. Yeah, even wanting to speak on this. Yeah, it's an it combines some of my favorite things in the world: sensory experiences, olfaction, gustation, right, taste, and pharmacology, right, the effects of drugs. But anyways, yeah. So given the fact that some of these terpenes seem to have sort of dominantly analgesic effect, right? In which seems to be the case with alpha humulene, the green kite there. It will be interesting to see if there are other, other terpenes that would be even further towards the analgesia effect, in which case maybe those strains tend to be more effective painkillers. And what would be really interesting would be, if this group or another group with the necessary equipment to conduct a study, if they talk to people, or maybe they themselves are quite familiar with cannabis, with the different strains of cannabis, that might enable them to sort of hone in on, okay, so there's like hundreds and hundreds of different terpenes that we could study. How are we going to focus on one and do all these behavioral experiments and electrophysiology? Well, if we know that, generally speaking, people who are using medical cannabis to treat pain, if they tend to always kind of go for the same strains, well, then let's focus on the terpenes that are present in those strains and then compare them in their analgesic qualities to strains that nobody uses for killing pain, right? Strains, and potentially some strains that exacerbate pain in some people, right? Let's compare those terpenes and see if it turns out, and blind yourself, the scientists should be blinded so they don't know. It'll be kind of tough because obviously these things smell, right? But blind yourself as best as you can, and then see, does it map out? In which case, these terpenes are way more important than I think pretty much anybody really suspected. So pretty cool. Did you speak on CBD and Delta 8 and stuff? So I did not talk about like the classic cannabinoids. I mean, I'll definitely do that in the future. I talked a little bit about, you said CBN. So I talked a little bit about THC and CBD, as well as some of the other cannabinoids that are present in cannabis, cannabigerol, cannabichromene. And I have a link to a study that actually, it's a review actually here. I'll just post it now just because, let's see. I think it's this one. Yeah, I think it's this one. Can you just remember? Yeah. Here we go. This is it. Okay, so if you want this link and you're watching somewhere else to this review, it's a very big review, but it is free. It's not paywalled, so you can check it. So you can check it without having to pay for it. But anyways, yeah, I'll talk about those other cannabinoids in the future. But yeah, this was cool just because like I don't really see any real serious science that focuses on terpenes. Because I think, like me and like I think most people, we just sort of like assumed, yeah, like they're meaningful because like if you're smelling something that smells like blueberries or whatever, or whatever, some of the other like pine-y, then that might influence just sort of your perception of the substance, which can sort of sculpt the trajectory of the effects. But never in a million years did I think that they would actually have pharmacological effects, like psychoactive pharmacological effects. And this suggests that they very well may. Some pretty good evidence suggests that they do. So that's what I have for, what link? Cosmic Rose. Yeah, so you can't see it on Twitch. So here, let me just do this, because I think I can post it on Twitch, can't I? I'll just post it now, so it's like there. So this doesn't completely destroy my entire situation here. Nope. Okay, where's the chat? Oh, I see it. Sorry. Boomer. God, Boomer. There we go. Okay. Thank you for reminding me to do that. All right. Yeah. So, okay. So that's what I have for you today. It's a fun study. There are problems with it. You should never take just one study as canon, right? I'm sure that there will be a subsequent study that suggests, actually, no, it doesn't. They actually don't have any pharmacological effects, but their evidence is pretty good. And I suspect that there's something to this. And so that's what I have for you today. If you dig this kind of conversation, maybe you'll consider subscribing if you're not on whatever platform you're watching, and liking and doing all those kinds of things. I really appreciate all the awards. It's really generous of you. I do really appreciate that. And thank you, Veda, at the end there. I really appreciate it. And thanks for watching, and I will see you next